I always wanted to work with machines that automated things. I spent the first part of my career operating, designing, and building them. My employer, Criticon Johnson & Johnson in Canada, asked me what my ultimate career goal was, and rather than give the standard answer of be president of the company or become wealthy, I wanted to give an out-of-the-ordinary answer and replied, I want to invent something useful that will contribute to society. After I said that, I asked myself, what were you thinking? You can't do that. After developing several new manufacturing processes there, I found myself reassigned to R&D in Tampa, Florida, and was told to invent things. I was terrified. I didn't know if I could do that, and I would be fired if I couldn't. Fortunately, I was on Julian Cannon's team, and not only was he a great mentor, but I also worked with some very talented people. We succeeded in developing new processes, and I got to keep my job. I worked with some amazing automation and developed things like laser shaping IV catheter tips and machine vision inspection. Mind-numbing activities such as manual inspections for hours on end looking through a magnifying glass were replaced by robotic cameras and computers. I worked with smart people like Zinovi Altman with lasers, Rick Madero with machine vision, and Jim Muscatello, an electronics wizard. Later, I was introduced to Rhine Medical in Tampa, and they introduced me to some great ophthalmologists. I joined them in surgery to observe and think of ways to make the procedures better. Although I still did work with arteries, veins, and bones, the human eye was the most fascinating organ, so I focused most of the past 35 years on that. Some examples: after watching how the incision into the eye was made for cataract surgery and how complicated it was, I designed a diamond knife that created a self-sealing incision into the eye that was done with a single movement instead of multiple cuts. It also eliminated the need for stitches that distorted the cornea, causing astigmatisms. With Dr. Dan Dury, I developed a wavefront sensor and miniaturized it from a tabletop machine to a small enough form that it could be attached to a surgical microscope and used during eye surgery. This provided live optical readings to the surgeon as the operation progressed. This device has helped produce better results for over 3 million eyes so far. I could not have done this without the help of Max Hall, a brilliant software engineer, and Jim Allen, who can build anything from a box of random parts. During the very first live eye surgery using the wavefront sensor, when I hit start, I got a message on the screen. Would you like to try a free trial of Microsoft Money? When I hit no, the computer crashed, and that 60-second reboot was the longest minute of my life. Although I'm no longer working on surgical projects, I'm still quite involved with human vision. In Sarasota, I'm working with an innovative group making the next generation of electronic optics that will change focus with no moving parts. For example, soon you will be able to use a small remote control to change the focus of your contact lenses. We are also developing these optics for use in virtual and augmented reality. One of my heroes, Thomas Edison, was asked how he invented, and he said, "It's 1% inspiration and 99% perspiration." Being a Florida resident, I do understand the 99% perspiration part. As I look back on my career, I now realize that success came with the help and collaboration of others and not doing it alone. If I may be so bold as to rephrase Thomas Edison, I think that inventing is 1% inspiration, 19% perspiration, and 80% collaboration.